Welcome to Chem Time.
Friends, welcome to the presentation. Today's presentation on fluid mechanics cover the concepts on density and specific gravity. We have discussed this concept in our previous presentation. We take a problem and solve it in this presentation. We also highlight the surface tension and capillary action in this presentation. I start the presentation by remembering Agnes Pockels, who has contributed significantly to the concept on surface tension. Madam discovered the influence of impurities on the surface tension of fluids doing the dishes in her own kitchen. Coming to the presentation, the problem in this presentation is a liquid occupying a volume of 0.225 meter cube weighs 1.89 kilonewtons. Calculate density, relative density, specific weight and specific volume. Specific weight is calculated as weight by volume. So specific weight is equal to weight, that is 1.89 kilonewtons. Kilonewtons are to be converted into newtons, and 1 kilonewton is equal to 1000 newtons. Therefore, specific weight is equal to 1.8 kilonewtons into 1000 newtons by kilonewton divided by 0.225 meter cube, the volume, which gives rise to the specific weight of liquid as 8400 newtons per meter cube. The mass of the liquid can be calculated as weight by g. G refers to acceleration due to gravity. Weight is 1.89 kilonewtons, that is 1.89 into 1000 newtons. Newtons can be expressed in terms of kg meter per second square. Therefore, mass is equal to 1.89 into 1000 kg meter per second square divided by 9.8 meters per second square, which gives rise to 192.86 kg. With a volume of 0.225 meter cube, the density can be calculated as density is equal to mass by volume. Mass is 192.86 kg divided by 0.225 meter cube, that is 857 kg per meter cube. Relative density, also known as specific gravity, can be calculated as density of the substance by density of the reference substance. And if the substance under consideration is liquid, the reference substance becomes water, whose density is 1000 kg per meter cube. Therefore, relative density is equal to density of liquid by density of water, that is 857 kg per meter cube by 1000 kg per meter cube, that is 0.857. If you observe the density and relative density does not carry any units, whereas density carries units. Specific volume is calculated as volume per unit mass. Volume is 0.225 meter cube divided by mass is 192.86 kg, which gives rise to 1.17 into 10 power minus 3 meter cube per kg. Before going to the concept on surface tension, we need to discuss that all the core branches of engineering are governed by three laws. They are conservation laws. They are law of conservation of mass, law of conservation of momentum, and law of conservation of energy. And fluid mechanics, which talks about the influence of forces on the fluid, deals with the momentum balance. Rate of change in momentum becomes force. So, first, the forces can be categorized into line forces, area forces, and volume forces. Line forces, the point of application of the force is along the line, and best example for line force is surface tension, which we are going to discuss in this presentation, whose units are newtons per meter. Area forces, the point of application of the force is the surface or cross section. If it is surface, shear stress, and if it is the cross section, it is the pressure force. The volume forces, these forces act on the entire body. The gravitational force is an example of the volume force. Coming to surface tension is defined as the tension of the molecules at the surface due to uneven distribution of forces present on the surface of the liquids. and this phenomenon is responsible for floating of insects on the water surface. When insects are present on the water surface, the weight of the insect acts downwards, and this weight of the insect is opposed by the surface tension force. Since the surface tension of water is higher than the weight of the insect will have to float on water. Now, a second example is a stainless steel blade placed horizontally on a water surface floats even though the density of stainless steel is higher than that of water. And this is mainly because of the surface tension of water. The weight of the blade is not able to overcome the surface tension of the water. If the water is replaced by detergent solution, and detergent solution is having less surface tension than water, and if the same blade is placed horizontally, the blade sinks because of reduced surface tension of the water replaced by detergent solution. Now, coming to causes of surface tension can be influenced by two forces. One is cohesive forces, the second one is adhesive forces. Cohesive forces refers to attractive forces between molecules of the same type, and adhesive forces refers to attractive force between molecules of different type. To explain surface tension, let us consider a liquid placed on a beaker. The liquid that is present in the bulk of the liquid does not have net force because it is equal, the force is acting equally in all directions. Whereas the liquid that is present on the surface will have uneven distribution of forces because on one side of the liquid it is water, on the other side of the liquid it is air. And this uneven forces, the cohesive forces and adhesive forces, leads to contraction of the liquid surface to smallest possible area, and this force is called surface tension, and the minimum area is that of a sphere, and that is one of the reasons water droplets take the shape of a sphere. Next, coming to capillary action. Capillary action is due to the combination of intermolecular cohesion within the liquid and adhesion between the liquid and the inner walls of the tube. When the adhesive forces between the liquid and the tube are stronger than the cohesive forces within the liquid will rise in the tube. This is the case with water in a glass capillary tube, where the adhesive forces between the water molecules and the glass are stronger than the cohesive forces within the water. As a result, we'll have a concave meniscus. On the other hand, when the cohesive forces within liquid are stronger than the adhesive forces between liquid and the tube, the liquid will fall in the tube. And this is the case with mercury in a glass capillary tube, where the cohesive forces within the mercury are stronger than the adhesive forces between the mercury and the glass, leading to a convex meniscus. In the next presentation, we'll be talking about the experimental determination of surface tension and order of magnitude of surface tension for various liquids. With this, I conclude my presentation. Thank you.
Request you to like, share and subscribe my channel.